Quadratic inequalities. Example. Solve the inequality x squared minus 8x plus 10 is greater or equal to 0. Now we first consider it as an equation. So we start with x squared minus 7x plus 10 equals 0. The solutions of this equation show where the graph y equals x squared minus 7x plus 10 crosses the x-axis. So we solve the equation by factorising it. We want two numbers that add to make minus 7 and multiply to make 10. They are minus 2 and minus 5. So x minus 2 times x minus 5 is equal to 0. Now that means either x minus 2 is 0 or x minus 5 is 0. So x equals 2 or x equals 5. Now the graph is a U-shape, and we want the sections of the x-axis where y is greater or equal to 0. So if we draw a picture of the graph and mark the points 2 and 5, the graph is above the x-axis outside the 2 points. This gives us x is less than or equal to 2 or x is greater or equal to 5. And we can represent this on a number line. We have 2 points at 2 and 5, and because the inequality has an equal sign, it means x can take the value of 2 or 5, so we draw those as filled-in dots. And then we shade arrows to show the region outside of those 2 dots. Our final solution is x is less than or equal to 2, or x is greater or equal to 5. So, to solve a quadratic inequality, we first solve it as an equation to find the roots. We then decide which sections, bounded by the roots, are required. Let's look at another example. Solve the inequality x squared is less than 3x plus 4. Now to solve this, we first consider it as an equation and solve it to find the roots. So we start with x squared equals 3x plus 4. That can be written as x squared minus 3x minus 4 equals 0, and we want to factorise it. So we look for two numbers that add to make minus 3 and multiply to make minus 4. That's plus 1 and minus 4. So it factorises as x plus 1 times x minus 4 equals 0. This means that x plus 1 is equal to 0, or x minus 4 is equal to 0. That means x is equal to minus 1 or x is equal to 4. So we know now that minus 1 and 4 are the boundary points. These points are not in the required area as the original equation has a less than sign and not an equal sign, so it does not allow equality. So the points are not filled. Now, the quadratic graph will either be a U-shape or an inverted U-shape, so we want either the region outside or between the points. To decide which, we can take a test point. So we choose a point that is not a boundary point. So for example, let x equal 0, and we substitute x equals 0 in the original inequality. This gives us 0 squared is less than 3 times 0 plus 4, or 0 is less than 4. This is true, so we want the region that includes x equals 0, which means we fill in between the 2 points. And this gives us an answer that minus 1 is less than x, which is less than 4. Now, the following is an exercise that you could have a go at yourself. Pause the video at this point, and then when you restart it, I will go through the solutions. Okay, let's see how these are done. In question A, we have x squared plus x minus 12 is less than or equal to 0. So we start by considering the equation x squared plus x minus 12 equals 0. Now we want to factorise it. We want two numbers that add to make 1 and multiply to make minus 12. That is 4 and minus 3. So x plus 4 times x minus 3 is equal to 0, which means x plus 4 is 0, or x minus 3 is 0, which means x is minus 4, or x is equal to 3. Now we can draw two circles above the number line, one at minus 4, the other at 3. Because the inequality has an equals sign, we fill them in. And now we have to decide whether we fill between the points or outside the points. So choose a point that's not one of minus 4 and 3. Let's say x equals 0. And substitute it in the inequality. So 0 squared plus 0 minus 12 is less than or equal to 0. In other words, minus 12 is less than or equal to 0. Now that's true. So 0 is in the required region, and so we fill in the gap between the 2 points. And this gives us minus 4 is less than or equal to x, which is less than or equal to 3. In question B, we have x squared plus 5x plus 6 is greater than 0. So we start by considering it as an equation, x squared plus 5x plus 6 equals 0. And we want to factorize it. We want two numbers that add to make 5 and multiply to make 6. That's 2 and 3. So x plus 2 times x plus 3 is equal to 0. Now that means x plus 2 is 0, or x plus 3 equals 0. Which means x is equal to minus 2, or x is equal to minus 3. So we draw this as a number line with 2 points above minus 3 and minus 2. They're left unfilled because we don't have an equals in the original inequality. We now have to decide where to fill it in. So choose a point that's not one of the two, minus 3 and minus 2. So let's choose x is 0 and substitute it in the original inequality. Now that gives us 0 squared plus 5 times 0 plus 6 is greater than 0, or 6 is greater than 0, which is true. So 0 is in the required region, which means we're shading outside the 2 points. So x is less than minus 3, or x is greater than minus 2. Let's consider question C. In question C, we have x squared minus x minus 6 is greater or equal to 0. We're going to consider it as an equation, x squared minus x minus 6 equals 0, and factorize it. We want two numbers that add to make minus 1 and multiply to make minus 6. So x plus 2 times x minus 3 equals 0. Which means x plus 2 is equal to 0, or x minus 3 equals 0. So x is minus 2, or x equals 3. Now we can draw that on a number line as 2 points, one above minus 2 and one above 3, and they are filled in because the original equation does have an equals sign in it. Now we need to decide whether we're going to shade between them or outside of them. So choose a new point, let's say x equals 0, and substitute it into the original inequality. This gives us 0 squared minus 0 minus 6 is greater or equal to 0. In other words, minus 6 is greater or equal to 0. Well, that's false. So 0 is not in the required region, which means we shade outside the 2 points minus 2 and 3. Which gives us x is less than or equal to minus 2, or x is greater or equal to 3. Let's have a look at question D. X squared minus 8x plus 12 is less than 0. So we start by considering x squared minus 8x plus 12 equals 0. Now, we want two numbers that add to make minus 8 and multiply to make plus 12. Those are minus 2 and minus 6. So x minus 2 times x minus 6 is equal to 0, which means x minus 2 is equal to 0, or x minus 6 is equal to 0. Now that means x equals 2 or x equals 6. We can mark that on the number line by drawing a dot above 2 and a dot above 6. These are left hollow or unfilled because there's no equals in the original inequality. We have to decide where we're going to fill it in. Now, if we try x is equal to 0 in the original inequality, we have 0 squared minus 8 times 0 plus 12 is less than or equal to 0. In other words, 12 is less than or equal to 0. Now that's false. So 0 is not in the required region. So we shade in the section that lies between 2 and 6. Now that means 2 is less than x, which is less than 6. In question E, we have x minus 3 times x minus 4 is less than 2. Now we start by considering it as an equation x minus 3 times x minus 4 equals 2, and we expand the brackets. This gives x squared minus 4x minus 3x plus 12 equals 2, and we can subtract 2 from each side and simplify to get x squared minus 7x plus 10 equals 0. Now we can factorize that by looking for two numbers that add to make minus 7 and multiply to make 10. That is, minus 2 and minus 5. So, x minus 2 times x minus 5 equals 0, which means x minus 2 is 0 or x minus 5 is 0, which means x is 2 or x is 5. So, on the number line we draw in 2 points above 2 and 5. Now they're left hollow or unfilled because there's no equality sign in the inequality, so x cannot actually take the value 2 or 5. Now to decide where to fill this in, we try another value of x, let's say x equals 0, and substitute it into the original equation. This gives us 0 minus 3 times 0 minus 4 is less than 2. In other words, minus 3 times minus 4 is less than 2. 12 is less than 2. That's false. So 0 is not in the required region. So we shade between the 2 points, which means x lies between 2 and 5, or 2 is less than x, which is less than 5. In F we have x plus 7 is greater or equal to x plus 1 all squared. Consider x plus 7 equals x plus 1 squared. We can expand the bracket. This gives us x plus 7 equals x squared plus 2x plus 1. If we subtract x and 7 from both sides, we have 0 equals x squared plus x minus 6. And if we swap the sides, we have x squared plus x minus 6 equals 0. Now we can factorize that. We need two numbers that add to make 1 and multiply to make minus 6. That's plus 3 and minus 2. So x plus 3 times x minus 2 is equal to 0, which means x plus 3 equals 0 or x minus 2 equals 0, which means x equals minus 3 or x equals 2. So, on the number line, we mark 2 points, one at minus 3 and one at 2. We draw them as filled in because the original inequality has an equal sign. Now we have to decide whether we shade between them or outside the 2 points. So we choose a point that's not one of the original two. Let's say, for example, try x equals 0 and substitute it into the original inequality x plus 7 is greater or equal to x plus 1 all squared. Now this gives us 0 plus 7 is greater or equal to 0 plus 1 all squared, or 7 is greater or equal to 1, which is true. Because this is true, 0 lies in the required region. And this gives us minus 3 is less than x, which is less than 2.